Hi, my name is Sean Willis. I'm a senior technical artist in Pipeline TDin working at Crafty Apes Visual Effects. Crafty Apes is a high-end, full-service visual effects studio operating out of the US and Canada. We always use the best tools for the job, and increasingly, more recently, one of those best tools for the job has been Bifrost. And today we're going to be going over how you can harness Bifrost to do procedural work and tackle more challenging problems a lot easier. All right, let's get started. All right, welcome. Thank you for coming to my presentation. I'm super excited to share with you our Bifrost journey, particularly through the graph. We've been long-time Bifrost users ever since the fluids became integrated into Maya. So I don't really think that counts, but just to be completely clear, we're talking about the graph in this one. So lots of cool stuff, lots of proceduralism, lots of fun. So I'm going to give you guys a brief overview of what the topics for today are going to be. The first one's going to be the most important, absolutely most important, not the coolest, but the most important, which is Bifrost graphs being used instead of render time geometry or VRE proxies or rental stand-ins. You can make highly specific edits and you don't have to re-export every single time you want to do something. So for things like wind in trees, for things like forestry, there's a lot of intrinsic detail. And with Bifrost, you can set it up and basically rig all of your stuff so that you can make changes on a very accurate proxy of geometry and have that either the active proxy drive Bifrost or have the active proxy be a quick viewport look into what the actual render time geometry will do, because you can apply the Bifrost graph to either of these meshes depending on which pipe it's going through, if it's going to the renderer or if it's going to the viewport. And you can have the viewport be really fast and give you interaction stuff and basically create a preview of what the render one will look like. Now, the next one, which is for user experience, is probably the big one, which is my attributes and Bifrost attributes can connect to each other bidirectionally. So you can drive parameters in Bifrost from Maya, and Maya can get parameters driven from Bifrost. So it allows this procedural hook its visual programming. So you can bring this big layer of logic, driving functionality in Maya that you want to automate or process or just do something with. You know, Bifrost has this whole diagnostic thing, and in the market menu, you can see you can turn on, proxies and diagnostics. Set up your graphs right, they can be really, really useful. in this capacity. So the third one is large-scale interactive geometry processing. We could brute force a lot of geometry when instancing wasn't available. So on this specific asset, every single piece of that is unique. You don't really want to have to drive it through a system that isn't procedural, and we'll talk about that more in the presentation. The next one is the coolest part of it, which is making effects. Really Bifrost's bread and butter, but this is going to be the meat of the presentation as well. Yeah, this one's cool. Erosions. Bifrost is really good at just processing stuff in general, and a lot of times it's as fast or faster than Maya. When you know what other things you can do in the graph, what things can be interconnected to one another, like in Bifrost's Boss, you can drive a boat with waves. In the graph, you have full control. It's not just this parameter that you have to tweak. It's not just a setting that you need to set up. You can inherently build it into your setup that you publish to other artists, and it gives you the amount of control that you would want, and it's unified in a way. So that's going to be fun. And then the last one, which is customizing and extending with SDK. So the previous one, actually, like this one, wouldn't be possible without this because you can't actually read images into Bifrost. But with the SDK, and what we did with the SDK, build a image reader. I'm going to be open sourcing that so that anyone can download it and build it and use it. Hopefully, we can get some collaborators on it because I am not a C++ developer by trade. I didn't know C++ and I was able to pick up the SDK. Without further ado, we're going to start with number one. So let's get started on how to actually create the LODs. I'm going to be using tools, but you can basically recreate this through publicly accessible APIs currently. Level of detail, add LOD input to graph. So when you select the fern, this is a custom marking menu, add LOD to graph. All that does is just set a custom attribute called level of detail that links to. Let's grab these transforms, set them all to 0, hide that, and we've got our fern right now, which is set to the render representation. And they're all in the same space. So here we have our scene, and the LODs are going to be able to drive instances as well. So I have this LOD switch, which is literally just switching, and then an instance LOD switch, which is grabbing the instance geometry types and porting that through the preview mode. And then we create instances that's after scatter. So it's a really simple Bifrost graph setup, but the power of this, if you have your inputs and then you apply some sort of deformation, or if you can rig these, set 333. And the reason why this is such a big deal is interactivity in the viewport. So when you set the level of detail to preview, everything's really fast, it's really interactive, you can do stuff. And another thing you can do is, let's say, hide the proxy and the render, is I'll grab a deformer, and I'll grab it, and it'll be really fast. I can even turn this off, make specific edits, and it'll just be there when you turn it on. So if you do this on the render geometry is going to process a lot slower because you're processing, 10 times as many, sometimes 50 times as many points. So I can set this, move things around, style the shape, and when I render, it's going to render the final quality representation of it. We can make something super, super drastic too. Just to really hit home this point, every single person in Maya should be aware of and should be using. So the next thing that we have here is a recreated scene for the process of the quantum core room on Orville. We had some concept art. We needed to bring that idea further, and it being a spherical, this setup in particular is spherical, we needed a very dynamic way of building it and iterating upon it. If you don't know what something's going to look like and you're creating what something's going to look like, you really want to go with a procedural way of doing it. When you're working on something intricate and complex, if you're not doing it in a procedural way, you may only limit yourself to literally one version. And that goes for both the artist is only creating one version, the supervisor's only reviewing one version, and then the client's only getting to see one version. Which isn't very flexible, and it's not a really ideal way of doing it. We're going to showcase the LOD stuff in action, so we can just right-click and load it, and we can narrow walls through camera clipping. So Maxime created this really awesome camera frustum culling, which we use all the time. I'll show you real quick what that looks like turned off, and I'll go back to preview to do so. There's our full geometry, which when you have all the characters all the railings, all of the arms, all of the stuff, and it's including the extended background. It's a lot of geometry. And at render time, you only really need it there. And you can't just cull it in the camera or clip certain areas. Otherwise, it'll affect lighting because it's a giant ball, it's a core that's illuminating everything from the core itself. So it's scattering and bouncing everywhere. You really want to be able to make changes and adjustments really quickly. And the way to do that is being able to rapidly switch between representations. But not only do you want to switch between representations, you want the representations to also inherit from one another. So right over here, I have, these really, really rudimentary pieces, and I want to possibly change their layout. So I'm going to go in here, change the culling so that only the points in view, because this is our camera that we're looking at through, we're like, okay, for this camera, this is a close-up. We really want to dial in a consistent look because you need to make it look appealing from a bunch of different angles. We set this detail down, and then we can change our sliders and have it go perfectly interactive. We can turn them all. We can get a couple in there. And then we can preview what the final one looks like. And I'll show you just for illustration purposes. When I drag this, it's still somewhat interactive, but it's not real time because it's just so much geometry. Yeah, so you really want to narrow down your scope and parameter for what's going on. So if I show the sphere here, this is the input geometry, and I move it, this is moving all the geometry. It's also not quite real time, so I'm going to set it to preview. There we go. Now it's faster. I can even just change the topology on this because it's not topology dependent. There we go. So I could set this to get it even faster, and of course move the camera around. So this shape really could be anything. Like you can squish it, deform it, do a lot of different things. And it's deterministic on the output result. So you can really have a lot of flexibility for what you're doing. You can assign IDs to be persistent. You can move cameras through it and have multiple cameras cull at the same time. So you can do a quick layout. Yeah. So that's it for this one. All right. So we're now going to switch over to a base disintegration setup that we use. It can be extended into lots of different areas from sci-fi to very realistic. And we're going to be going over some of the ways that you can use it. So first off, we're going to start with the background, because the background, you need something that things are going to collide with. So here I have a setup that loads in a height map for digital elevation. This could be LiDAR. This could be lots of different things for formats. It could be drone footage that you took. And we're just elevating it purely in Bifrost. We are grabbing our proxies in here again. And to get this to be really fast, we'll just set it to preview just so we can get the base shape, not using the render representation. So here we're reading in an EXR, and then we deform it using this custom compound image deform parallel, which just takes the height of it and puts it into 3D space. So we update the normals, set the color to something a little bit darker, and we compute it on the frame. The reason we want to compute on the frame is that we don't want to sample the EXR for every single frame. Otherwise, this playback would be really slow. So that's what this here is for. So, and this next one, which is the disintegration. So this is the graph that creates disintegrations. We have 4 inputs here: the level of detail, the ground for the collisions, activation, and the geometry. So the activation is a optional thing that basically you can mask out certain areas that you want particles and ones that you don't. So it's entirely optional. It's completely up to you. And we have some colliders in there, so something to throw it at. And you can group all of this into a single one. I'm just showing you what the graph insides look like. And up on this top right corner, this is where the rendering stuff happens for Arnold. If you're rendering outside of the graph, what you want to do is you want to convert it to a board, and that way you can use it to control your render layers. So you can output different things into the different render layers. Because currently, Bifrost doesn't have any shapes that it's actually outputting. But in this, the body chunks area, we have body particles and body chunks. These are actually Bifrost output shapes from the board that then you can add into your render layers, and you can split them out by that. So the big key here, and the reason this is so important, is that there's a lot of layers to this. There's particles, there's chunks, there is a lot of different ways that you can build this out. And we want to wrangle all of those things. And this simulation is all in one single node. So we're taking our sparks, which is here, and our source chunks, which is here, this graph, and we simulate them so that they can collide with each other. And they can also collide with the environment as well. And we also have simulation bounds. So the simulation bounds can say, hey, let me go outside of here. Here's just a region. So we only want to collide with the region there. Now this is fairly flat just because he's standing on solid ground, but we could put this anywhere over here. And we could scope out just that area for collisions and just this bounding for where we're simulating particles. We can see the base thing. This is pre-simulated. And you get obliterated and it doesn't go outside of that bounds and it's colliding. And through the level of detail, you would actually set the collider to that level of detail that you need. So if you need it to collide just in this area on the high res, you can say, okay, just for this area, use the high res, slice it up, do that. So this guy getting obliterated. The source input can technically be anything. You can have, it doesn't need to be a single mesh. It doesn't need to be a single-sided shell versus a solid volume. So let me just show you this. This is our source input. You can grab multiple things, bring them in there. So our man, that's where our geometry is going in. And that's what gets output. Now I want to show you something real quick, mostly because one of the big features of this is getting colors into Bifrost. The more keen of you might have seen this avocado here. I'm going to grab these two. So this is the avocado that's in there. And I'm going to grab the image to surface points. I'm going to replace that with this one. So point geo, all right? So now we're sampling, rather than we're doing the spark emission mask, we're doing this avocado, which is a textured avocado. And we're going to set this to pass-through mode so that we're re-simulating. And we're going to re-enable the graph, go back to our start frame. We're going to play through. And now we have, oh, well, look at that. Well, that's pretty cool. We've got colors and we've got avocados. The reason I chose bright green is that all the examples that we had were like really desaturated and they didn't actually show any color. So I elected to do something a little bit more interesting and a little bit more visible for compression and stuff like that. So now we see, and also everyone knows what an avocado looks like. So you can see like over here is where the the outer area is, and this is where the pit is. And really, like, this kind of shows you the versatility of Bifrost, is that this object is so much smaller than the dude. And we didn't change anything to have to tune in like how many particles in there. It just did it because we designed it to work wide array of possible inputs. So that's pretty cool. I'm actually going to switch this back and I'm going to reuse this one again because I don't want the sparks to look like avocados. I want them to look like sparks. So for this one, the mask points, this is going into the chunks, and this original one, which is our spark emission mask, I'm going to go put that back into the geo and show you what that looks like in combination with the sparks so that you can visualize what's spark, what's not. So now these things are simulating and they're getting obliterated. Yeah, so now we've got avocado getting obliterated and the sparks are above the other area. We might want to add a little bit more noise in there because it's really showing us the separation of that. But that isn't necessarily something that we want in the base setup. That's an override that an artist would come in and add. So already we've got a pretty interesting looking particle effect. And if I just turn this back on to read mode, our dude, who's a very boring gray, unfortunately, this is the same setup. So this one looks a little bit cooler because he has other things driving him. So when you're doing these types of shapes, there's a secondary input that you can put in. We can turn this off, this collider that is a presim of the chunks. And you won't see this, these specific particles doing what they're doing and falling over, because like sometimes we want the entire thing to be obliterated, and sometimes we want some particles left over in the stead that was there. So I'm going to show you what one of the inputs driving this is, which is the body chunks. Now, the body chunks was one of the main reasons we ported so much stuff into Bifrost. Is these took forever to actually calculate and create outside of Bifrost in any other system. So here's the one where this is the chunk system. This is an NPM system. Some of the effects are more rigid, where they have a lot more pieces, and some of them are more like them getting completely vaporized and obliterated. And to support those two things, it's in the same system. Usually you'd create two different systems, but here we have the same system doing it. It's just whether or not you're utilizing the NPM part versus using chunks. So this is following a pattern. And this pattern that we're following, if we grab these nodes up here in a new graph, just grab these. So this is a graph that does a surface fracture on the geometry. It doesn't do a volume fracture, but this file cache is in path-through mode, so it's calculating it's not reading something from the disk. Ah, beautiful. So if we hide these two parts, this is what's going to define our source for our NPM. And these are meshes. So Bifrost can take points, mesh them, and give you a very interesting surface detail. So there's a variation on these points that I'm putting in here, where I'm changing the point size to make it look a little bit more burnt and have a bunch more holes. So this splits up the mesh into a bunch of different parts that is going to drive in a very art directable way, because it's loading it from this image, this spark emission mask. So the spark emission mask, you can paint it, you can just grab it straight in, you could have it be a procedural input, and it can just drive certain areas. And you can set this up however you want. So if I turn off the point size, if I reconnect the point size, also when you're doing stuff like this, this is also why you would want to use LODs, is so that when you're crafting the final look, you can do it interactively without, having to pause and wait, because we're processing the full res mesh every single time. And this is like the final output. So this is a lot of polygons. So naturally, doing all of these conversions is going to take a little bit of a hit. So that's what it would look like with just the straight up paint mask. So we've got some really interesting details here. This is a procedurally generated 2D bitmap. And usually what we'll do is we'll procedurally generate it and then paint on top of it to have specific areas that we want to art direct, while still having the ability to, when we don't need that art direction or paint over, you don't need to add on top of something. Like, it's already good to go. It will give you something that's highly appealing. So back in our body chunks, make that visible. So that's what this NPM is being derived from, is it's actually like being driven from a fracture. And this is a fairly low res NPM sim that we're doing, just so that it stays interactive. But the same way with our geometry, our sims should have LODs. So in this disintegration setup, if I go back here a second, and I right click on it and I go level of detail preview, it shows me the non-colored, non-RGBA, slightly smaller, slightly less particles in there. And you should be able to sim stuff quickly, where you have smaller amount of particles while still getting the rest of the motion in place, which is what Bifrost is extremely good at. You get results that kind of scale across resolutions. And we have the proxy, which is like slightly smaller. And then we have the render, which really it scales up the particles. It makes them much fatter, and it changes their point display to being spheres. So now, and even at the final resolution, this is playing back fairly fast. We can get it 24 frames a second if I turn off like everything else that's calculating in the scene. But that wouldn't look as cool. So we're gonna do this. And now let's go to this secondary fork off of, you have this mesh and you actually wanna have like a bullet simulation or some sort of rigid body interaction if that's the look that you're going for. And some of these, they needed that. You bring them into a separate Maya scene, and you can basically plug them into a bullet sim and have Bullet calculate these. So here's our bullet sim. We go, okay, cool. We're outside of the other ecosystem, mostly because Bullet doesn't exist in Bifrost. I would love for Bullet to be in Bifrost. That would make this entirely self-contained inside of the Bifrost graph. But yeah, this is good enough. And we can, export this as an Alembic cache, which we load that in here. We could just to visualize it. You can see we've got our simulation. Boom. So if it's needed, we would probably want to split this up into more chunks for demonstration purposes. I elected that would be fine. And a lot of the times when you round trip to Bullet, you have no UVs. So because there's no UVs, you can't really texture it if you had a digidouble, because it's in this completely different mesh structure. It's been triangulated down, so none of the UVs are going to be usable. So all you really need to do is just transfer the points from one point space to the next point space. And Bifrost can do that fairly easily. You can do it to particles, you can do it to meshes, you can do it with color sets. You can do basically any type of transformation in there. Usually you wouldn't want to have to query it every single time, so there's various ways that you can optimize that. But it's almost always possible. Almost always possible. So this is our little demo graph that we're making. And yeah, let's see what this all looks like together, shall we? Let's go to view, composition. Boom. There we go. And this also works on an avocado. We like cake a lot at Crafty Apes. We have bake-offs. And I really wanted to put a piece of cake in there, but I didn't have time to scan any cake and put it in there. So we get an avocado. All right, cool. That does it for the vaporization setup, which is reading Bifrost data into the Bifrost graph. So the boss ocean system is legendary in my mind because ever since it came out, I have used it for literally every ocean I have ever done since. Haven't touched any other frameworks, haven't done literally anything. It is always giving me the best results, and it's unparalleled in its basically the look of its waves and its speed at which it does it. So what I'm doing is you can't actually, as far as I know, I could be wrong, is you actually can't create these waves in the graph, which is a real crying shame. And I decided that I wanted this ocean in the graph. So this is another use of the reading of the EXRs. If I turn this off, that's the graph representation, and I set out the boss output. So this is the playback speed through a cached representation. So this is the large waves and the small waves. And this is boss's own stuff, and they're caching it. They're caching it to EXRs, which is awesome because we can read those with our fancy new tool. But these are cached, and this is the in Maya boss cache. And when you play it back, this is what you get. You're blending the two, so you have more parameters, and you can tweak it, which is good. But it's 1.6 frames per second for, let me display the poly count, for about 250,000 faces. So I like working faster, so I'm loading both of these. Now these are the same resolution EXRs, so I can verify that for you if I got the boss output, which once you selected it. And I go to the large, and I go, okay, project cache object. This one is that same path. So it's untitled small, untitled large, which is reflected over here. So when I read this in the graph, all of a sudden, I'm lying to you because I'm reading it. We'll do pass-through mode. That's more like it. Now I'm getting 1.9, 2.2, which is almost twice the performance of the other one. It's still not fantastic, but it's still twice. So when you're making changes, and you're like me, and you already know what the specific waves that you want, you can export all your layers, knowing that you're going to isolate regions, you're going to paint color sets to bring in specific details in specific areas, and really make the effect in the graph. You'll actually have a faster time doing it if you output it to EXRs and then do all the blending over here. So I'm reading two of the items, I'm getting their RGBAs, I'm multiplying this one by a factor, and then I'm adding them together. So I'm doing the same thing as this boss blend node, but I'm doing it with a little bit more control and a little bit more speed. And of course, I can also cache this. So the thing about boss is that you'd have to export out to an external cache every single time, every iteration. And here, like, you can just cache it, play it back, and then make iterations. There's no throwing it out and bringing it back in. It's a bit more convenient. I mean, that's literally what we're doing. We're throwing it out and bringing it back in just twice now. But if you're like me and you want the speed and you're comfortable in the graph, this is a much better area to do that. And even in the case of if you're not using boss, you could publish this as a compound and just say, hey, I recreated all the parameters that boss has inside of the Bifrost graph through EXRs. I mean, that'd be a massive waste of disk space, but you could do it and it could work. So yeah, Bifrost devs, if you can put boss in here, I would love it. So this brings us to the final part of the video, which is all about the custom tools, custom compounds. So the first thing that we have is this camera rig tool, where if I turn on this diagnostic, there's a camera path and it flows through that path, and you can visualize where deviations in that camera path. I mean, this is not a real camera track, this is just a simulated one, but there's a bump in it and you can see it's highlighted in red where the deviation is there. Some cameras are a little bit shakier than others. When there's large sweeping cameras, and you don't want an editable motion path, because that's a feature in Maya. You can add an editable motion path. If you just want to visualize it, it's very convenient to just have it built on the camera so that when you turn on or off the diagnostics, you can just see these things. And this one is a fully automated field that you can visualize in Maya. So we can change the focal length, and we have our custom field of view make an appearance here. This is, once again, Maxim's excellent frustum culling compound, and another excellent one from him called Update Strands Curvature. When you view through the shot camera, you can see the cameras passing through this field. And these are really easy to see when cameras falter in depth. So you can see the ones closer, they'll show you more of these issues. They're also kind of annoying to have in your scene all the time. And wherever the camera goes in space, you want to be able to, read that in. So if down the line a camera gets transformed, you want to still have that validation data for you. This field is entirely procedurally generated. It doesn't exist. So if I turn this off, it's just, there's no polygons here. If I go to display, heads up display, and I go poly count, there's 0. This is free. You can just turn this on and off, and wherever this camera goes, so if I go to the last keyframe, the last keyframe, and I move it, W-Shift-D, our field has moved along with the camera, and our curve has also done that. So, automatically. So when we go back to the shot camera, I need to adjust the scale for this, but you can basically have something that's always where the camera is, no matter where it is. The thing that makes this possible, because currently Bifrost evaluates per frame. So you get a frame, it calculates, and it happens. The magic behind this is this custom node called fetch on frame. Not fetch on frame 2, just fetch on frame. And what this does is that it takes an input and it samples it throughout the timeline, and then puts it into a Bifrost object and passes basically time sample data into an array. And then Bifrost can go and grab it all at once, and then for every frame, spit out what's been processed. Next up, we have one of my favorite ones, which is a camera projection setup. So what we have here is we have our EXR image sampler, and we have a sequence of images. And if we change the frames here, now this is a massive 4K, and this is the terrain from earlier. That's why it takes a little bit of time to process. But it changes, and it's actually playing this footage of fire. And this is also fully interactive and floating point. So if I turn it to log, you see we recovered detail. Whereas if I set it to raw, it's blown out. But it has this full range of colors. So it's a full high resolution, high bit depth representation. And all of these are points. So when I zoom in, the reason why this is scrolling so slowly is because Maya is generating all of these on the faces and on the points. So we're projecting, this is a raycast. So that's the reason why it's not super interactive, is that it's not being computed on your graphics card. It's being computed per point. It's shooting off a ray, seeing what it hits, and doing intersection. And it's using the camera inputs inside of Bifrost. So we grab it, we calculate the field of view from the film back and the focal length. We grab the field of view tangent, and then for each of those items, we shoot a ray, we calculate a direction, and that direction goes into the raycast. So these are the Bifrost nodes where you can sample a raycast, you can sample the point position and the point normal, and you can set the positions of the images. So this is the alternative method for if you don't have UVs or you need to project something. Ideally, you would probably never use this for texturing. This is just for getting colors in there to further process and do computations on. So yeah, as the ecosystem evolves, there'll be smarter people than me that can build more optimal algorithms to do these types of intersections and to make these a lot more fast. Because these are just me creating stuff so that I can get a result. And then as soon as I get that result, that's the end of the tool. I'm happy with it. I'd like to make it faster, but usually I have no idea how to. So it ends there. And let's go. So I'm just going to quickly run through all the custom examples. We have our LOD switch. We have a visualize components node, which actually is pretty useful for development and polygon modeling. So if I create these two primitives, I'll grab one at a time. I didn't build this with the array inputs in mind. I put a diagnostic on it. This node basically does the same thing that our Maya diagnostic does. So if I duplicate this, it's live, and it's the exact same as what you would get in Maya. It's basically how I validate our topological tools, and it's super useful, and I'm going to be sending this on the Bifrost Addicts Discord. The reading and writing of EXRs. So this started as just a general project that I wanted to try to get projections and image data, because there was a lot of things that was going to happen, and I wanted to see what you could possibly do, because I didn't think I was going to be able to write this. And that's also a testament to the ease of use for Bifrost and the ease of learning and the whole ecosystem in general, is that I was able to build these, and I didn't really have a production deadline, but they became used in production immediately. As soon as I had them, I was like, oh, there's like half the things I'm working on have applications for the EXRs. And these were built with the SDK. So previously, we used a Python plugin, and then we would port the data through a Maya port. And that was far less efficient because it was going through, translating, reading, all that through all the ports. Now we have it with the SDK in 2.5. We can read them directly in the graph because they created an operator interface for that. And so these are C++ plugins, and they're OpenEXR 3 point something. It's the latest EXR, so they're fast and they're very good. They're fairly limited. I'm going to be open sourcing these, and hopefully I can get more features in there, like layering and indexing and stuff like that. That way, you can sample specific parts of an image rather than having Bifrost, cut into a specific area of an existing point, because we're translating the points. And then we have image to surface, image to points, and these two just. One of them slaps it on a surface using barycentric coordinate sampling, and the other one just 0 to 1, it just puts it there so you can see it. This is more of a debugging tool, but it also has its use cases. And then we have image to vertex color. That one's one where previously what you had to do is you had to texture it and then you have to bake it using Maya software. Now we can do all of that inside of here, and we can just iterate through and sample all of these And then image deformation, that's like literally just a texture, a texture deformer. This works exactly the same as my texture deformer, and it slightly underperforms it. So it's only like 0.3 or 0.4 seconds if you're moving interactively of a difference. And then we have our image to film back, the project points, which is what was used here. Yeah, and that's it for the image operations. The camera rig uses a match orientation to rotate stuff along with it. So as you see, when we're moving our camera, these rotate along with the camera, so they're always facing it. And there's an option here to not have it do that. Let me go to the graph. This one doesn't have a marking menu just yet. But yeah, you can either turn off use custom geometry so it has points, or you can turn off screen aligned. And that just, rather than rotating them along with the camera, they just sit there in space. So you can really just build out really smart things, and anyone can go in and start messing with things, start adding features. And I do mean anyone. So we're gonna do some bonus tips and tricks. It'll be like a bit of a lightning speed round. I've got 10 of them for you. The first one being join online communities and read the documentation. Two of the great ones are Bifrost Addicts Discord and the Autodesk forums. I highly recommend the Discord because it's where the majority of communication and collaboration and just like a think tank happens there. There are really smart people on there. There are Autodesk people on there, and it's a great community. Then there's the Autodesk forums. These are best for questions and feedback. Like getting help with stuff. And the reason I say that is that the Discord doesn't show up in search engines. So a lot of the times it's better to have, that type of discussion so that other people can, access it easier. The second one, which is something I ran into a whole bunch. And, I think anyone new to Bifrost needs to be aware of this, which is open face shells versus closed holes in converting to volumes. So a lot of the times when you're doing like cloth or something, you'll have topology that you won't even see because you have open hole faces. So you really want to either close those holes before you use it as a collider or do any type of volume conversion, or you need to set the volume mode to only be calculating the shell. So just be aware of that. Property fields. So this is one that I don't really see anywhere on the internet or in tutorials. There was something in the Bifrost Discord, but I want to bring more visibility to it, which is changing simulations after the particles have been sourced by properties. So you can use the property proxy fields, and the screenshot shows you how to do it where you're changing things based off of stuff after the initial sim. Because these are all on the source particles, but if you want to animate or modulate or change something after the fact, this is how you access those properties, and this is how you do it. You just have to make sure that they're plugged into the additional properties on the source particles node. The next one is frequently changing your background viewport color. So a lot of the times when you have volumes and densities, the current viewport background color, whatever you have it set to, might not be the best one. So you're going to make sure that you cycle through those so that you can get a better grasp on what your densities are, especially if you're doing aero sims. Number 6 is connecting nodes from afar. This is one that I didn't know until like embarrassingly late in my Bifrost journey, which was how you drag and drop from far away connections. In Nuke, I'm just used to just scrolling around somewhere while dragging down. Bifrost is a little bit different. 7 is rapidly connecting connections. You can't like select a bunch of connections and connect them all at once. So the best alternative to that is alt dragging and dropping a pass node on a bunch of the same typed connection. The next one, which is modify simulators and extend them. This one's a fairly advanced one. It's kind of daunting to actually go this deep into the nodes. But the power of doing this is pretty incredible. The fact that you can just open up these massive networks and like see how they work, it's great. Bifrost command. So this one, if you wanted to bring your setups into Nuke and have them execute there, you can do that through Bifrost command. You just have to tweak your setups so that they're a little bit more specific. And last is the display parameter values in the title. So here I have the frame range, and the frame range is actually visible on the node title. If you create a property node, you'll see these, but it's really useful to create them in your own nodes. So how you would do that is I just open up a text editor, and then modify it so that it's asking these attributes what they are. All right, cool, and that's it. Thank you all so much. This has been a privilege for me to demonstrate for you. I hope you've been inspired and that you've learned something. You can join the community and really get going and expand your realm of possibilities procedurally. Thank you very much.
All right. Hi, everyone. I hope you enjoyed this session as much as I did. I was just telling Sean before this how amazing those human and avocado disintegrations were. My name is Rob. I'm a marketing manager here at Autodesk, and I'll be moderating our Q&A session with the wonderful Sean Willis from Crafty Apes. How are you, Sean?
Doing great.
Awesome. So before we dive into the first batch of questions, I just want to remind everyone that you can still submit some questions in the Q&A box. We'll be checking them as we're answering questions, so ask away. All right, Sean, first question for you. The audience wants to know, do you have any ideas of other SDK projects you'd like to try?
So we use SpeedTree a whole lot in traditional Maya sense. We use their dedicated plugin. But we want to actually build a SpeedTree engine from the actual SpeedTree SDK into Bifrost so that we can procedurally work with the trees rather than exporting them to like FBX or Alembic. That way we can actually like have the SpeedTree procedurals be driven and exported from entirely within Bifrost because that would be a really powerful leveraging of the SDK as well as like the third-party usage of of Bifrost SDK with the SpeedTree SDK. So basically taking the SpeedTree engine, implementing it in Bifrost, as well as Bullet. Bullet is super useful in a lot of production contexts. And in the presentation, we used it in the Maya plugin. And we definitely want to explore using it directly in the graph because that saves a lot of time for exporting things directly versus just having it be a node that just continues passing through. So that one's definitely one we want to explore. The next one's the LiDAR reader. We actually use Bifrost basically to mesh all of our LiDARs that we don't get from Recap. So if we get raw data from our clients, we always remesh it in Bifrost because Bifrost can handle the very, very large, massive data sets properly because it doesn't run out of memory. It doesn't crash on these massive data sets. So we use Bifrost to actually like remesh, convert it to a volume, mesh it on top of there. So we want to have more ability to read in a larger amount of formats, so like XYZ, E5, 7, things like that. So building a translator for that so that we can mesh stuff in Bifrost, we'll have all the photogrammetry part of things just directly inside of Maya. And you can work with stuff on that. And then the last one, which is a camera perspective matcher. 3ds Max has had this application, like this little tool that you can put lines on there. There's also an open source one called FSpy. Maya's, because it's like a film tool, I would love to build that directly inside of Maya because for a lot of times I'll go into Max, use the perspective mesh tool and export a camera. So I just really want to build that directly in Maya. And Bifrost, the way that it can interactively visualize stuff, it's really good for tools like that, where rather than have it be this large endeavor for development that makes this like kind of small time-saving tool, when you make that tool in Bifrost, making the tool is not only kind of fun to do, it's also more time efficient because it takes you less time to actually do it. There's not this whole dev process of building and compiling and making it. It's just something that you're building directly in the graph. So the camera perspective matcher probably won't be an SDK specific thing, but it would be like a Bifrost thing.
Awesome. I love the detail in that answer. So are there going to be example scenes released with any of these setups that you showed during the presentation?
So none of the ones that are directly related to shows, we would never release any of that type of data. There is on GitHub, you can download the OpenEXR translator and all of the compounds that go with it. Eventually, I'll get an example scene that showcases the usage of all of those things. The majority of that's covered in the presentation, like you saw how the image reader and the deformers all work. But having an example scene is always useful for people who want to just see how it works before they possibly integrate it into their pipelines. Or just see like what the limitations are of what it does exactly. I think would be useful. So yeah, there'll be some ones that are completely non-show related, but no show related ones will be released.
Got it. So how long did it take you to get into Bifrost, and did you have any knowledge of ICE before getting into Bifrost?
I had never used Softimage or ICE. I've used Maya the majority of my career. And also when I was learning, Maya has been the primary application that I've used. I picked up Bifrost as soon as it was released, as far as the graph is concerned, like the day it was released. I started opening it, going like, okay, this is awesome. And I used Bifrost like as the arrow and the water simulator. Like also, I think it was released in 2016. I'm not entirely sure, but as soon as that was released, I'd also picked up that. So I have a lot of familiarity with the terminology and like the way that it's being used before the graph was actually released. But the key to actually like picking this up quickly is determination and sticking with it. Because there's a lot of conventions that like the Bifrost graph is not a traditional node graph. It's compiled on the fly. So when you change something, the graph recompiles, and no other system does that. They're built with, you know, a different type of architecture. So there's a couple things where you're like, once you learn I wouldn't necessarily call them quirks, but once you learn what the software is capable of doing, you want to put a lot more stuff into it. You want to be like, oh, this is really effective for deformers or for rigging or for, you know, procedural trees or, you know, whatever, because you have all the power and all of the control. Like it gives you full control over everything. There's no limitations when you're inside of the graph as far as like computationally. It's very limitless as far as like an interactive user experience. Like you don't have to, you can build stuff from scratch without, you know, having to have a lot of experience in the actual, you know, system itself. Like you could be a math person and you could immediately go into Bifrost and be like, oh, you could be a programming person. You know how to program, you'll feel right at home because it's just visual programming. And if you're an artist, you're going to be looking for the compounds, the high level stuff that allow you to work in a way that one area drives another area. So yeah, it took me, I've been using it since 2019, and we've been using it in production since 2019. The very first production we used was not okay with this. And yeah, we used that to basically drive the trees falling over and like the debris being kicked up. So that a lot of that was all stuff that didn't exist in Maya at that point. And as soon as it was released, we're like, we got to show we're going to use this on. Let's do it. And yeah, and it was a learning process in the middle of it. And I would say a testament to its usability is that we were able to get results that were photorealistic and worked for our show without actually having any experience in Bifrost through the runs of production.
Great. So you mentioned using Bifrost for 3 years now. How much Bifrost is being used in Crafty Apes for production? And how would you say Crafty Apes artists are liking Bifrost, and what would they like to see in the future? A couple questions in there.
Yeah. Crafty Apes is being used at Crafty Apes. Its adoption right now is we have tools and we have processes to execute really complicated work. And it's not fully in your face as far as like an obvious way of doing this, because there's a lot of ways to execute the same type of work that Bifrost can execute. But where the threshold of complexity hits the ceiling, where you run into the limitations of the software itself, like Maya, when you have these massive point clouds or massive data sets, usually Bifrost at Crafty Apes shows up when you've hit a limitation somewhere and you're like, we can't do this in anything else. So historically, from like 2019, the initial inception was we were hitting that ceiling and then Bifrost was bailing us out, right? We were hitting a ceiling, we're like, all right, nothing else can do this right now. And we'll use Bifrost to do that, which was, it was almost like a last resort, but the last resort has slowly been becoming our first option. So for things like scattering, hopefully we can deploy that in a much larger sense where we're replacing V-Ray proxies or Arnold stand-ins with procedurally generated stuff that isn't, you know, it's not limited in that nature to accelerate other stuff. And like with the EXR sampling, like in Maya, you had to do a bunch of things to bake stuff to a color set. You had to do a bunch of things to read particles in. There's a way to do it in N particles, but it's way simpler in Bifrost, and it's a lot more powerful when it's in Bifrost because you're not connecting expressions. And there's also visibility. Like if you use N particles to do something, there's a lot of expressions that you might use that aren't super easy to pick up. And in Bifrost, it's a lot easier to pick up because it's in that graph. You can look at it, and because you can compound stuff, you can group things, it will allow you to, at a high level, understand what's actually going on, albeit if you build your graph elegantly and don't make it spaghetti, it'll be super useful. So yeah, I would say there's only a couple people that actually author graphs currently at Crafty Apes, but there's a lot of people that consume the data that it uses, and there's a lot of people that consume Bifrost externally, where they run something that does a Bifrost operation and they get a result back, and they may not even know that it was generated in Bifrost or used in Bifrost. So there's a difference between active users and passive users. Majority of people at Crafty Apes currently are passive users, and with this presentation, I'd like more of our Crafty Apes people who are doing effects, who are doing lighting, layout, to become active graph users rather than static consumers where they're just executing a command, the command is doing something in Bifrost and giving you a result. Because you can be a lot more effective and a lot more control if you actually are available to go into a graph, see what's going on, understand it, because it's not super hard to pick up. And since it's built into Maya, like there's no reason not to, because you're already in Maya. You don't have to go outside somewhere else. You don't have to export it to a third-party plugin. It's there. So yeah.
Awesome. So I think we can squeeze in one last question. Quickly, can you give any more detail about how the simulation for the phaser disintegration effect was customized to achieve the really cool look that we saw?
One thing that I don't know was super clear in the presentation was how you actually split the particles, because they're all simulated in a single simulation node. So the key to that is you can set a property on the particles. It can be like that one particularly, because there was only 2 in the presentation, was just a 0 and 1. So one of them was sparks, one of them was not. It's a simple Boolean. You can set any type of property with any type of type. So you could create your own IDs for the particles in Bifrost and filter out the particles at render time. So one of the things that we did was filtering the particles and then changing the velocity so that the sparks would have a specific length independent of the shutter speed. And one of the big limitations that we ran into with timing in particular was that Bifrost handled variable time rates really well, and it didn't get in the face of the people that we were handing off to, where it was like, okay, these spark trails are too long, or the shutter needs to be changed, because we want to keep the camera at the specific shutter. We don't want to art direct with deviating from what the camera was actually being shot at. So we needed stylistic sparks that had trails that were really appealing and nice, but we didn't want to deviate the actual camera itself, because that would be physically incorrect. So Bifrost allowed us to art direct that, where we could put trails and things, adjust how many time samples we had to get a really nice looking arc in the sparks that were turbulating through space. So I would highly recommend simulating everything as far as particles and like NPM in a single one, so that things can collide with each other. Because a lot of the times, like when using different systems, the systems simulate independently from one another. And in Bifrost, you can simulate anything with anything. Well, majority of things with majority of things. There's some conversions that may happen, but you can open up the compounds, you can assign properties. You have as much control as you possibly could imagine to easily art direct stuff. And you can expose that as a parameter. So if you're the author, you can make something that says like, spark trail length. Set that as a parameter on your top group. And the artist who may not be super familiar with Bifrost can load that in and be like, oh, I know what to change without having to, go into it and be like, okay, where is this thing? Change this value over there. So yeah. Compounds didn't exist previously in Maya. You couldn't group things in the node editor. And now you can. So, well, not in the node editor, but in Bifrost you can. And then you can have those Bifrost nodes be in the node editor or be in your scene, versus like the board versus the graph.
Lovely. Well, Sean, we're at time, unfortunately. I wish we could go through a couple more questions. But thank you so much for joining us and showing us all the cool things that you and your team do at Crafty Apes. It was a real pleasure chatting with you. And to the audience, thank you for asking questions. And I hope to see everyone at an upcoming session. Thanks, Sean.
Thank you all.